everybody, welcome back to Mrs. Baker's Chemistry Corner. This is the paper 4 monster paper and it is question 3. So molten nickel iodide can be electrolyzed using the apparatus shown. So we've got molten nickel iodide. We'll underline that. We know we've got molten, not a solution. During the electrolysis, charge is transferred through the copper wires and through the molten nickel iodide. Now, in the type of particles which transfer charge through the copper wires. Well, the key word here is wires. Wires are made from metal. Metals have free-moving electrons. Name the type of particles which transfer charge through the molten nickel iodide. Well, of course, nickel and iodide are both ions. Predict the products of the electrolysis of molten nickel iodide. Write an ionic half equation for the formation of one of these products, so you can choose. So the products, you've got molten nickel iodide, you haven't got a solution, so you've only got Ni plus, Ni2 plus, sorry, and iodine, which is iodide minus. So the products must be nickel metal and iodine gas. An ionic half equation, well, you can choose which one. If you were choosing the nickel would be Ni2 plus, which would have to gain to E minus and make nickel metal. Or you could, if you were writing for the iodine, you would write I minus makes I2, so you'd need 2 I minus and would give out 2 electrons. Either one would get you the mark. You don't have to write both, but either one would get you the mark. A student electrolyzed copper 2 sulfate solution using the 2 sets of apparatus shown. In apparatus A, the student used carbon electrons, so let's write that down so that we acknowledged it. And in apparatus B, they used copper electrodes. Student made the following observation. So the mass of the negative electrode increased in apparatus A, the mass of the positive electrode stayed the same, and bubbles were seen at the positive electrode. In apparatus B, the mass of the negative electrode increased, the mass of the positive electrode decreased, and no bubbles were seen at the positive electrode. Of course, that's because in apparatus A, you are going to have oxygen here, so this would be O2, and you're going to make, at the anode, you've got copper ions going into solution. That's why. Explain why the mass of the negative electrode increased in both sets of apparatus. It's because copper metal is deposited in both circumstances. Name the gas that's formed, seen in apparatus A. Well, of course, it's going to be oxygen gas. Explain why the mass of the positive electrode decreased in apparatus B. It's because the copper metal forms Cu2 plus ions that go into the solution or the electrolytes. Probably actually better to write a solution is okay word, but it's better to write electrolytes. Okay, so now we can go across and have a look at part 4 here. Suggest what happens to the colour of the solution in apparatus A and apparatus B as the electrolysis progresses. Well, in apparatus A, we've got inert electrodes. So with inert electrodes, you don't replace the copper ions. So the colour is going to fade. And in apparatus B, the colour will remain because we keep putting copper ions back in. So let's go and write that up. Colour of the solution in apparatus A, they are both blue. You can write greeny blue if you like. Apparatus A, the blue colour will fade. And in apparatus B, it will remain the same. So what's the explanation? In A, the copper ions are being used up, and in B, the copper ions are being replaced. You can add by the anode if you want to be really, really specific. And if you want to be super specific, you say the copper ions are being replaced by the anode at the same rate as they are being used up. So what we don't want to do is imply that the copper ions aren't being used up in B. So just writing that they're being replaced at the same rate really doubly confirms that you know they're still being used up, but they are being replaced at the same rate. Okay, that's the end of question 3. On to question 4, I guess.